Next slide. So we are Azure user group dedicated to fostering a thriving, respectful, and friendly professional experience for everyone. We welcome and support all members in safe and inclusive environment where everyone can scale the cloud together. Our core principles are purpose, be inclusive, and be friendly. You need to listen and avoid criticism and always be professional. Yeah, next slide. So on today's session, we'll have our speaker, Dev Suchoi. I hope that's how it's pronounced. I'm sorry if I butchered your name.
Okay.
He's a Microsoft MVP, also a DevOps and Azure infrastructure as code. You'll be taking us through No Secrets Left Behind, a secure dev container from the ground up. Thank you and welcome.
Yes, thanks for having me. Awesome that we can make this happen. Let's see if we can get some educational session going. Shall I take over the screen? A sec. There we go. All right. So, can you see everything? Can you see the intro?
Yes.
All right, awesome. Then let's just start. For today's session, No Secret Left Behind, we're going to talk about a secure approach for dev containers. We're going to do it from the ground up. For everybody who's listening in, rewatching this, if you have your setup correctly, you can actually, during the demo, try to follow me along and do the installation on your own machine. And we have to pray to the demo gods that everything will work. Probably it will not, but that's the part of that's the fun part of doing this. So, speaking about demo gods. All right. So, who am I? I'm Jeff Sugoy. I'm a cloud consultant. I focus on architecture, engineering, excellence, and security. I run a devjeff.nl blog where I post cool stuff basically that I find, where I share my knowledge. So yeah, if you want to have a look, go ahead. It's .nl because I'm located in the Netherlands, which is quite a distance from your place, but these days with the internet, that shouldn't be a problem. And on GitHub, I'm part of a very small community called the Cloud Explorers. You can see the URL on the screen as well. There's a group of about 5, 6, I think 7 people that share all kinds of stuff. Share snippets, codes, any kind of demo material, and it's not just Microsoft related, because some of the community members are actually Linux experts. So it's a combination of a lot of from the Microsoft sphere in combination with open source. And obviously the whole setup is open source, and I highly suggest checking that one out. There's a lot of materials that have been gathered there over the past couple of years. Yeah, I'm a big fan of automating things. That's why you see this boy with the remote control machine as my logo, because it takes me a bit back on how all of this started for me, which is I used to get gifts from my parents, like some kind of a car or any kind of small toy. And the first thing I did is I actually grabbed the screwdriver and all the other tools from my dad, disassembled it to look how it looks inside, and then obviously ended up in tears because I could not assemble it back. Hey, fast forward many years, I'm still doing the same thing, but this time with Microsoft Cloud technology. And in this case, the good thing about the Microsoft Cloud technology is that if I can't assemble it back together, simply throw it away and build a new one. And that's why my personal motto is let's automate the boring. And from that aspect, I try to automate as much as possible. So, agenda for today. Well, we're gonna, instead of installing and building tools locally, we're gonna try to use a containerized deployment where we use Dev Container with Docker and build a local container to improve our own security posture locally and plan for a setup that can be used in a remote configuration as well. So why am I doing this? Well, my personal mantra is that security is everybody's responsibility. In a cloud world, we cannot say, well, SecOps or security team, or this is your problem, you have to gatekeep everything. That's no longer possible. Not the way technology works these days, especially not with AI. So if we do that, we can turn our very sad DevOps guy, security guy that's trying to help out DevOps into this. Yeah, and speaking on this subject, let's jump a little bit into statistics. Why? Well, because statistics. I wanted to see if I can make this session a bit more specific to your home country, if possible, or at least a region. So I ended up finding the Global Security Outlook, which is from the World Economic Forum. It's a huge PDFs on, hey, what's up with security? And it had some cool statistics about this. The first one is something that was asked to organization leadership, saying, okay, what is your organization's greatest challenge to become cyber resilient? And as you can see on the top, there are two topics here: rapidly evolving threat landscapes and emerging technologies, and third-party and supply chain vulnerabilities. And obviously, the first one is very important, as it is 61% answered, that one as being the top. However, 46% answered about the third-party and supply chain vulnerabilities. And that's what we're going to zoom in today. But let's see how that looks if we separate things by region. So, pardon me, we have a heat wave here, so I'm trying to not sweat too much. So the next question that was asked is, does your organization's workforce have the skill set that is required to meet your cybersecurity objectives? And as you can see, for Sub-Saharan Africa, about 63% said, no, we're missing critical people and skills. So with this session, I'm hoping to tilt that 63% to slightly less than just the 63%. And maybe we can upskill, at least with regards to the topic on supply chain attacks, etc., with this session. Let's deep dive a bit. We're going to talk about development containers, but I'm not sure that if everybody knows exactly what it is, so let's cover basics first. Development container is a specification, and that specification allows a engineer developer to define a repeatable development environment for a user or a team of developers, which it actually includes the execution environment that the actual application needs. So it's basically running a local container and running all your development tools there, keeping them closed in that space without polluting your local environment, both from a organizational perspective, but also primarily from a security perspective. So it's the development container defines that environment, and you develop your application before it's ready to deploy. If you're doing this for engineering, it's less crucial, but if you're doing this for developing C#, Python, or any other kind of code, you can actually try and mimic your production environment in this container as close as possible, which should improve your shift left, or basically reduce the amount of errors and surprises that you get when you put your code at a certain point into production. Well, the closer your development environment is to production, the lesser discrepancies and risks you have with development. For engineering, like infrastructure as code, it's a bit less important, but yeah, it's still a thing. What is it? If you open your Visual Studio like code, that's at least my IDE. Practically speaking, the dev container spec is a JSON file called the dev container, which lives in a special folder called dev container.devcontainer. Right? So why would we use dev containers in this case? Well, they are ephemeral by design. Containers can be torn down and rebuilt from scratch, eliminating any persistence. So if an attacker on AI might be misbehaving, that is for a majority of the topics, it's contained within that container. So when you kill it, the whole thing just stops without affecting your host environment. It creates an isolation boundary. For example, when you're using any form of AI, like a Copilot, GitHub Copilot, it is actually confined to the containers file system, process, network namespaces, any kind of packages, any kind of scripts. So if your AI runs away or you give it YOLO permissions to everything, it is refrained in that container and anything that you configure as part of that container. So you cannot get your runaway AI, which is YOLOing, cannot easily get outside of that container. Well, another reason why it's a good idea to do this is a sandbox execution. Every script runs inside without touching your host. So any kind of potential malicious configuration or drift, dependencies, etc., are not touched. This is especially true when with regards to supply chain attacks, which have been happening recently quite a lot. Even GitHub themselves got their source code compromised. And this happens often through packages, extensions that become infected. By running this in a dev container, you're containing those infected packages, extensions to that container run space. And finally, it's a reproducible environment. If you automate the boring, you can reproduce it and theoretically get the same results every time. Same OS version, security patches, everything is defined in a dev container. And finally, you can get a control mount, which is explicitly defining which directories are visible to the container. So this is where you define, okay, these folders I want in like read-only mode from my host to my container. These folders I'm okay with doing more. And another nice one to have is a clean terminal. So when you explicitly define which directories are visible, etc., you have a very clean terminal to operate. Reduction and proneness to mistypes, etc. That's where dev containers also help. So, architecture overview. Let's dive into how this is set up locally, because you need, when running a dev container, there is a bit of additional configuration required, and there's some preparation required to be able to do so. So, start from the bottom. We have a hardware, a laptop, desktop machine, and there's a hypervisor there, typically in Windows. In this specific setup where it's Hyper-V. On top of on top of that, on top of the hardware, we have our Windows 11 host. It has a Windows kernel, like any Windows system, and it has a user space where the user is operating. To configure the dev container, there are a couple of more components that needs to be installed and configured. Oh yeah, sorry. That user space is where your VS Code runs. You do your editor configurations. You have your source code, your UI extensions, and the actual dev container extension. So this is one of the prerequisites that we're going to need later. In addition, when we do the installation correctly and we set everything up, what happens is we're spinning up a WSL2. This is a extension that basically runs on any machine that's Windows 11 latest patched, a lightweight Linux utility VM with a Linux kernel. And I'll show this all during the demo. On top of that, the first thing that gets installed is a WSL2 distribution. In my case, I'm installing an Ubuntu, but it can be anything. Inside that WSL distribution, we have Docker Engine installed. So on my own host environment, there is no Docker Engine. I don't have Docker Desktop or anything like that. It really runs just as an engine inside my Ubuntu container. It is defined by a Docker file. In the example that I'm using, I have a bicep.-dev container Docker file. So I have a specific environment to build and develop bicep infrastructure as code. So it's completely tailored to that environment. It contains a base image, a common utilities feature. I have a prettier feature to make things pretty with regards to my command prompts, etc. I have GitHub CLI, which is important for me with regards to GitHub runners. And I have Act SDF, which is an additional feature. I do a Docker run. That Docker run creates a container. So inside that WSL distribution, which runs inside a lightweight utility VM, which is then runs inside your Windows 11 host on top of the hypervisor, we're actually running a container, which again has Linux has its distribution, and in my example case, it's again Ubuntu. Inside that Docker container, I have PowerShell, Azure CLI, I have Bicep CLI, GitHub, I have Act, which is a GitHub's action runner, which enables me to run GitHub actions locally. Cool debugging tool. Because of the way Dev Container works, a VS Code server is injected into that container, which allows then to have the VS Code extensions to run inside it as well. So I have on the left side, I have the UI, the terminal, the source control, Explorer, editor, the whole VS Code, while the content of it runs actually on the right side in the Docker engine. So what does that mean? VS Code Server enables us to do a full editor features like we would in our local environment with a local configuration. It has an integrated terminal which shows all the terminal commands, etc. We have the same IntelliSense. We can do the same debugging, and we can do the same file operations. On top of that, a workspace is executed or mounted from the Windows host, which is basically the repository, or in often at least the folder where you usually put the repository is automatically mounted as a workspace. And for the secure feature setup, what I do is mount a key vault file, which is in my case dev container vault.kdbx, which is explicitly set up and bound as a read-only. This way, whatever runs in my container cannot modify any of the keys and setups in there. And we'll see that hopefully during the demo. So, before running, a couple of prerequisites, like I mentioned, either Windows 10 version 2004 and higher, build 19041, or just latest version of Windows 11. We do need VS Code because the dev container extension is the one that communicates with that VS Code server that runs there. And for my example, I have a KeePass or a KeePass XC, which hosts all of the secrets and setups that I usually use. So let's talk about, let's go slightly back. So what you see here is that we actually have a dev container and a Docker engine that runs a Docker part combined with the dev container. That's not per se a configuration that you have to run to be able to execute dev containers. This is my setup. And why am I doing this? Let's talk about that in the next slides, because I'm actually running Docker and dev container, and I do this on purpose. Because you can theoretically just run dev container. It still runs, launches a Docker image, but I'll show you later what happens if you do that. So I separate things out. We talked about the developers, engineers, that you can share this setup and let them reuse it in a uniform manner. To be able to do that, I have a Docker image, and this is where I define any tools that I need to have to do my job. So this is my development platform. And in the dev container, I define the image, the configuration on how I want to do my job, which is my developer experience. So in this setup, the Docker image is a fixed thing that everybody from the team gets with the prerequisite minimal setup of a team, what the team needs. So if you have a team of engineers doing infrastructure as code in Azure, you give them a specific image. If you have maybe multiple teams, one Java, one .NET, maybe you give them slightly different Docker image variations. And the dev container part is something that we provide as a basis, but then they can build on for themselves as their personal development experience. So summing up, development platform required for every developer, version controlled, immutable, works independently of VS Code, can be reused in CI/CD pipelines. You can theoretically run the same Docker image in your CI/CD. You compose it, build it once, and you can use it many times. And the developer experience is very VS Code specific, easy to change without rebuilding the whole thing. Personalization and workflow focus, so every developer puts their unique config here, and it depends on the workspace in VS Code. And finally, instead of using env files, loading things into parameters, etc., we're using, in my case, I use a KeePass, which is bind mounted as read-only. It's decrypted only in memory through PowerShell, and therefore no plain text is stored in the container. Plain text secret is stored in the container, should actually manage. All right. I hope we have very, very friendly demagogues today. Let's see if we can do some fun stuff and go through this through a demo. Right? Oop. So let's move this aside. Let's start with a bit of setup. So the core of Dev Containers exists on containers.dev. This is where you start. If you want to start from scratch, go here. There's a lot of documentation. Basically, anything you need is set up here. And as explained here, let's go back. There are a couple of ways of using Dev Containers. We can use images, Docker files, and Docker Compose. Well, you can use an image as a base, do the Docker file, and finally do a Docker Compose. However, Docker Compose is more of a way to have a multi-container development environment where you have a container for a database, you have a container for a front end, back end, etc. So that's a bit, that's like a next level complexity with regards to containerization. I have here right now, let's zoom in a bit, a very, very simple image, and let me close everything else a bit. Let me reopen it otherwise. Okay. So I have here, let's delete even this, close the whole thing, and try again, and start really from scratch. So I just have a folder here, which contains nothing but a folder. And I know it's screaming that it's setting up the dev container, but it shouldn't be doing that. So I'm a bit surprised why it does that. Because we shouldn't have anything here. Interesting. It's actually building one. Can we close this? File, open folder. Let's see, what else do we have here? That's an interesting one. As I said, maybe we haven't prayed to the demo gods first. Okay. Not sure why it was doing that. Probably because I was playing around with setting them up. Let's start from scratch. So before we get here, let's do some prerequisites. So what you need is you need to make sure that your machine has virtualization enabled. And you can do that in your BIOS. I'm not gonna, like, every machine is unique, so I'm not gonna go through that. There's a very simple way of checking it. And that's this option. I hope it's a bit readable because I can't zoom in on the screen. It's virtualization, and it needs to show enabled in your task manager. If you have that, then you have the hardware prerequisite to be able to run the dev container. So next, we need WSL installed. And if you, to install WSL, you simply run, if you have the latest version, you simply open your command prompt. My case, for example, PowerShell, you should have WSL. In my case, it's already installed, as you can see. But if you want to install it from scratch, you actually do WSL -- install, install, and then you can say either a specific image that you want to install, or you can just run install, and then it will install the default image, which is, I believe, Ubuntu 22.04. So let's go and install 2604. It will download the image and execute an installation. We can also, in the meantime, open another window. Let's zoom in as well so that everything is a bit easier. Double SL -- list, and then I think it's verbose or online. No, that's what I have. Line, yes. So if you're not sure what is available, simply type WSL list online, and you'll get a list of valid distributions that can be installed as part of the WSL feature. So if you're not sure what WSL feature is, it's Windows subsystem for Linux. Look it up. There's plenty of explanation. So in our case, what we're doing in this tab of PowerShell, we need to create a user, obviously, and we will need to create a password. Let's do devjav as user and do a random password that I have here. Okay, so we actually now have WSL installed with an image, and you can do multiple image installations, and I'll show you. So I already had running a Ubuntu 22.04, and what I just did, I installed Ubuntu 26.04 as a second one. So initially we saw this is what we were running. If we do the same command again, we can see that actually have two containers at 22.04 and Ubuntu 26 as well. And we can mix and match those how we want. If everything is successful, there should be something like this, a very pretty penguin, which would, in my case, it's a shortcut to the Windows subsystem for Linux settings. And here you can specify pretty much anything with regards to WSL, processor count, memories, etc., to go ahead. And that's pretty much it. Right now, if I type WSL, I do enter, and you can see it automatically goes into one of my running containers, instances of WSL in this case. So with regards to setting up WSL as a prerequisite, that's pretty much it. The next step is actually to set up the dev container part. So while this is running in the background, simply create a folder, put that folder in it, dev containers, and inside that folder we need one file called dev container container.json. If you go back to the site, the very, very simple thing to do is simply specify an image that you want your dev container to run in. In this case, it's the base Ubuntu. Select it, go to the settings and do rebuild. And if everything is correct, you can click on this, by the way, and it will show you the log that's building. You can see it's starting. You can see all the commands. It's doing any kind of extensions or anything it has. It loads the whole thing. Start run container, and I think it's up and running now. So if we would check for this version, usually even if you can even configure it to open there we go, a separate terminal. If we do lsb release -a, we can see that we're running the base Ubuntu container inside the WSL, which is also Ubuntu, which then runs inside that virtual machine image, which runs in my Windows 11. With regards to containers, we're pretty much there. So we can expand on this. So for that, I have let's close this one and let's open another one, because let's extend on, of course, It restored my workspace. File, open, folder. Oh, why are we stuck? I think that's this one. No, that's the one we just did. Yeah, this is the one. Yes, awesome. So we can extend on this. We can start. Let's reopen this one in a container in the meantime. You can see the whole setup is starting. And if this one is configured correctly, we should have, and this one will take a bit longer because we have Docker here as well. This is the final setup. Yeah, there we go. And yeah, I think it's running now. Let's see. Yes. So let's go through the extended version of this. Again, we started with a dev container.json, but in this case, I also have the bicep dev container Docker file. But let's go step by step. Instead of, like the documentation initially said, specifying an image, we specified actually a Docker file next to the dev container, which is then explicitly referenced to as a build and then a Docker file. So what it does, on top of the dev container, it actually compiles the Docker file. On top of that, so let's just dive into the Docker file. So this is my reference. It's very simple as it is. You can even call it Docker file. So what do I have in my Docker file? First, my Docker file is also based on a Ubuntu image, in this case 2404. And I'm pulling it from the Microsoft Container Registry, which is a really awesome place because most people don't realize this, but there's a whole mcr.microsoft.com. If you navigate there, you have any kind of image here. Of any time. You want PowerShell, you can go for a PowerShell image where there's already PowerShell installed. You don't have to take care of this. You can even have Azure PowerShell. Oh, apparently there should be AZ PowerShell. Is it not how it is? Yeah, there it goes. AZ. You want a Java set up as a baseline. There is a Java development container image. There are different variation of it. There's a playwright, there's a functions, etc., etc. So I chose in this case a clean Ubuntu 2404 image to start with. Next, I define a couple of runtime dependencies. So first, I want apt-get install to get all the certificates, all the stuff. Then I have something called bubble wrap, which helps with Copilot to switch between different run spaces. I have socat for port forwarding, and I have something that helps with the extension called Better To Do, like a sublibrary. Then I install Azure CLI as part of my base image because this is my bicep dev container image, so I want my Azure CLI always there. I have kubectl and Helm for AKS related stuff as part of my base image. And I also do something I really like. My go-to standard command line is PowerShell. So I make sure that my PowerShell is default as my default runtime for my VS Code user. Finally, I do actually install Bicep as well. I verify that it runs. And my final step is I install a couple of PowerShell modules to run the whole setup, which helps me. Terminal icons, rules, etc. And obviously Secret Manager, which is what I'm going to show you in a sec. So that's all container. You can mix and match. You can choose, I want to set certain things as baseline in my Docker file. And in some cases you say, no, I want it to be more flexible, because majority of these things can also be defined in a dev container. And this is done through features. We go back to the website of development containers. Let's see. So we have something called, well, obviously the specification, metadata. If you ever need to set up the JSON file, it explains everything in detail here. Then we have the templates, which are the base images if you're not running Docker. So that Ubuntu that I just showed you is also, there it is. It's specified here as well as part of your template. And finally, the features. And features are community supported features that you can add. They are kind of like a dev container spec in that you can add on top of your dev container. It can be anything. You can do that same Azure CLI that I just showed you. We can add bicep here as well. And it's a strategic choice. Do I add it to the Docker file or do I add it to the dev container one? It's really up to you and your team how flexible you want this set up. So first, you always start with a common utils feature, which you set up some stuff like upgrade packages. I always set them to false because I want to be in control of upgrading them. Do I want the non-free ones as well? I set my username to VS Code or anything else. And as you can see here, I have a pre-tier package. I have GitHub CLI here. And I have ACT, which allows to run my GitHub flow locally. Again, I have the same setup here, but I'm just showing them as an example that I can run both of them. There are some other things that you can do, and one of the coolest one is the customizations. You can customize all kind of settings about your VS Code that is executed in that dev container. For example, my default integrated terminal is set here to PowerShell. I have certain types of files excluded so that they never get inside, like secrets.local, etc., environment.local. Then I can specify here the extensions that I want to run inside this container, and those are actually VS Code extensions. So if I go here to my extensions, you can see these are my local installed extensions. And these are the extensions that are actually running right now inside my dev container. These are specified here. As you can see, the list is identical. Then I have a mount, which is a file mount to my dev container vault.kdbx, which is this key vault file. It's a demo file. I added some secrets there just to show you some cool stuff with it. And I have a post create command, which makes sure that this the key vault gets registered within the PowerShell module. You can do more stuff here. You can forward ports. You can set your remote user to a certain setup, etc., etc. Just take some time, read through the documentation, and you'll know what you want to set up. Basically, we look at it, that's pretty much it. We have the Docker, we have the dev container, and anything, as you can see here right now, in the path, I'm in /workspaces dev container. So nothing like, let's say, who am I? Oh, there we go. You can see that I'm actually running root right now. So I'm running root inside the dev container. There is no Windows. My whole environment is not available. So if I would open GitHub Copilot or any kind of other AI that helps me with my coding and programming, it also has only access to whatever is available inside this dev container. You can see I only have like three sessions in my history, because those are the only sessions that were executed from inside this dev container. This the GitHub Copilot instance that runs right now, it is not aware of my localhost Windows 11 machine, which is a very cool thing, because you can kind of keep it inside here and give it either more permissions or play with it, etc. So that said, we can also make certain secrets, etc., available to this dev container from outside from the host machine. Like I said, I have here a dev container vault, which contains all kinds of secrets that I want to use inside my dev container, but I don't want it to be stored there. I don't want it to be accessed through the terminal, etc. So for that, I've set up a this extension called Secret Management. Actually, this is the actual extension, and this is the module, and this is the module to make it integrate with KeePass. So after installing this, mounting this KeePass file, I'm able to, if we do it correctly, see, there we go. We have 1 volt available for us through that mounted drive inside the dev container. And obviously, we first need to log in through a master password. You do this only once, like in the morning, or when you log in and start your dev environment, and hopefully I have the right one. There we go. And I can list all the credentials, all the secrets that I have in my on my local machine inside this KeePass. If you see, we have exactly the same setup, including the test secret, that are available to me inside the dev container. So, for example, what I can do is I can do a get secret, then give the name, and let's say test secrets. You can see I have access to it, but it is rendered to me as a secure string, which makes things, I can decode it to a regular string, and I can actually use it to set up, for example, a connection to Azure. So let's try and do that. So let's take which ones do we need? We need the, give me a second, the tenant ID, we have the client ID and client secret. So theoretically, we should have all the information we need to set up a Connect AZ account. So let's see if we can do that. Okay, give me a sec to. We can also force things into plain secret, like I said. So for example, this is my client ID of the app registration I'm going to use for this demo. Don't worry, I'll delete it right after it. If we pass the as plain text switch, we actually get the actual item, but that's not what we want. We want to have the tenant ID and the client secret to be stored here in a variable. Then we want to get the actual password, which is the client secret, and we're not passing the switch as plain text because we can pass it as a secure string. So we have the client secret now, and let's check here, client secret. Oh, there you go, secure string. Then we can create a credential object based on the client ID and client secret. And finally, we can do a connect AZ account. And there you go. It connects to my demo tenant without exposing any of the secrets, any of the sensitive information to an AI, to anything that runs inside the container. So my secrets are immutable. They are mounted as read-only in a KeePass. This KeePass is then configured during the Dev container and the Docker compose setup to become available inside the Dev container, and I can maintain them here outside without worrying that I might lose this credential in any way. And this can be done for specifically with this setup with PowerShell. This can actually be done to any kind of login authorization that you have. If you're going to do a web invoke REST API with those kind of calls, you'll probably end up with a bearer token or something like that, which needs to be plain text. So that's a bit less secure, but that's more in the nature of the authentication method itself. All right. So let's jump back to the presentation and talk about the usage, the go, no goes for this. All right. So anti-patterns. Well, as you see in the meme, we can theoretically take the Dev container and put them in Kubernetes. It's considered a bad practice to run the Dev containers as production staging applications or Kubernetes, container instances, or any kind of container orchestration. The way they're set up, you've seen it set up with root, etc. You would need to harden it a lot to be able to run it as a secure container. There are different tools to be able to do that. So this is not something you would like. I would not use them as a CI/CD build agent either, again, for the same reasons. The essence of it is that those containers are set up in a way that enable your development process. So it's not a good, secure environment for CI/CD either. And definitely don't deploy them as microservices. Then a final one is treating the mounted workspace volume as persistent application storage. That's also not something, but that's more specifically on not how to use the container, but how to configure it. Don't treat the mounted workspace as persistent application storage, because then you're kind of killing the purpose of abstracting everything inside a container. So how can we apply it? What's a good way of doing it? Well, you can upload the dev container to GitHub as a package, and I'll show you an example of that in a sec. We're not going to upload it, but I'll show you for a colleague of mine and one of the contributors for Cloud Explorers has already done this, which we can use as a template. Next thing is you can also use that same dev container in GitHub code spaces. That way your environment no longer runs local. It runs inside GitHub code spaces. Obviously, you do need to have code spaces. It's not, I believe it's not a free feature either. So, but then you do not need the WSL, the whole Docker runtime, that whole setup. You don't need it. You just push it to code spaces and you don't have to worry about it. So it's a bit of how much do you want to tinker yourself. It's definitely advisable to use pre-built images instead of building the container from the Docker file like I just showed you. You could also, so otherwise it's going to be built every time you open it or you rebuild. But you can also push that pre-built image to GitHub container registry or an Azure container registry or anything else and pull it from there. And then that will save you the compile time. Yep. And that's pretty much it. So before we close up, let me show you here. So this is the, let me show you a bit. So this is the Cloud Explorer's GitHub repo. As you can see, we have a couple of contributors here. Lots of cool stuff, 37 repos to all kinds of open source stuff to play with. And this goes for every GitHub org. Basically, there is something called GitHub packages. And you can see we have a couple of them here. We have the Dev Container template. We have AI Foundry. I don't even know. Oh, that's an AI version as well. And we have an engineering tool set up as well. You can see it's been downloaded 62 times. So if we would click on that, you can see the versions that are available. My colleague Wesley, who has actually done the work for this, so big props to him, and documentation on how to use this as a template. So you can see the link, copy the URL image, set it up, or add it to your dev container.json. So we could theoretically do that by killing this container. Let me see if we can trash it. File. Sure why it keeps reopening the same folder. Container demo. Let's take this one. Remove. There you go. So theoretically, we should be able to take this image, just paste it here, and rebuild it. And if my colleague, there you go, has done his work correctly, and it seems he has, almost. Okay, so there's something wrong with this container, but I'm sure we can fix it. But the point is, you can basically edit it locally. You can specify the image this way, which you've tested, set up correctly from your own GitHub org, where you define them as part of GitHub packages, and you can simply pull from that. That way, it saves a lot of time as well to push things. And that's pretty much it from my side. So thank you everyone for your time, effort. Thanks for listening. If you are interested, I'm happy to connect. Hit me up on LinkedIn. Otherwise, check out my blog and definitely check out Cloud Explorer's GitHub repo. There is a blog post that explains at least the part about the KeePass in more detail, which you can find on my blog, which has a QR code in the top left corner, and the Cloud Explorers with all the demo material is on the top right corner. So Samuel, back to you.
Yes, Jeff. So I have a quick question.
Sure.
So I saw something about a shortcut for WSL. What's the name of the shortcut?
You mean to install WSL?
No, there's this shortcut that you showed about showing the different processes.
Ah, like that. Yeah, sure. Let's just go to, because there you go. I'll put them on the screen. These are the commands that I was basically using for WSL. So the core one, and it's actually like this, WSL -- install -WSL -min -d, And to check which versions are available, you do the WSL list online, and it will show you basically what version you can type here. The ones that you're already running is the one that is verbose. And then you can obviously, one of the things you should definitely do is, let's get out of this container. You run WSL update. You can see mine is currently running on the most recent version. And you can check the version that you're running through WSL. Yeah, there you go. You can see the whole thing. Does that answer your question?
How about the other one that was showing the amount of memory for the current WSL instance?
Yes.
Yes.
Okay. So the easiest way of doing that is actually going to your Windows and typing WSL after you've installed this. This is actually the command. I have it pinned on my desktop because I do speak about it sometimes, and it shows the memory processor, etc., that is configured for the WSL, shows how much disk space you want, networking, etc. And
Nice,
if
nice.
you can do all kinds of configurations here, you can do DNS tunneling. You can like it's quite a deep dive on how you want your networking. Do you want a NAT mirrored? You can like lose yourself in all these settings. You can make it as complex as you want. There's some developer tools. There are some optional features. There's so much stuff to configure here. But this is the WSL part. On top of this, you actually run the dev container. So this is a prerequisite because I have, if we go back to the architecture, final page, where are we? There we are. Slightly zoom out. So this Ubuntu WSL distribution is where the Docker engine runs in. So if I would open that same dev container, I would type Docker here. There you go. See, Docker is installed here. If I go to my local environment and I type Docker, it should not be visible at least. Or yeah, there we go. See, so I don't have Docker installed in my host OS. As you can see here on the left side in the user space, is actually running here as part of the container. So you, outside of the features of WSL, you can also like simply type WSL and you're logged in into the terminal of actually these settings. You can look them up through the terminal as well, command line. But for people that like to discover this, often the user interface is slightly more user friendly. Got any other questions?
That's my takeaway from this session. Thank you. Thank you
Okay.
for that shortcut. I've never used it.
Yeah, I can imagine. When you start working with the dev containers and the whole setup, it's gonna, that's a bit too much. There we go. It's gonna be something that you're probably gonna visit a bit more often.
Yes, yes.
Any questions from you, Gilbert, as well, or anybody else? If not, then again, thanks for listening.
Thank you. I'll just follow it up on my own pace.
Yeah, I can imagine that helps for the first time. All right.
Yeah.
So that's it from my side, guys. Do you stop the recording or what are we doing?
Gilbert, maybe you can wrap it up for us.
Okay, so is it Jeff or Have? Um,
Jeff, whatever you like.
um, yeah. So thank you. No, it sounds like a Croatian name, but yeah, thank you for taking through us this insightful section. Um, the recording will be live at our YouTube page, so that's something to look forward to. And we can't really express our gratitude enough for us, for you showing up, taking the time, and showing up and showing us new things. As Samuel has mentioned, he has also learned some new things. I have also learned some new things. I try I try go through the recording multiple times so I can understand. So I'm not that much of a fast learner. So it will take a bit of time. But if any question, I'll just hit you up at LinkedIn. Yeah. So thank you for the session. For everyone who has attended, thank you. The upload will be there shortly. So thank you and have a good night. And for Jeff, I think it's morning. So
No, I'm actually on the same zone as you guys are, so I'm just 1 hour earlier. So you're on 9, I'm on 8. So for me, it's also good night.
okay. And yeah, I hope your country wins the next match.
We'll see. We'll see.
Yes.
Thanks for the support.
Okay. Thank you.
Bye bye, guys.
Bye.
Bye.